Hambini fans, and welcome to another episode of French Engineering Superiority delivered by a 5-year-old Frenchie. In today's episode, representing that well-known French colony of Tunisia, we have this. Now this is a Lux 695. Now we have had a few Lux 695s on the show, but this one is a light version. And unsurprisingly, the chap who brought this bike in has had a few problems with it, so it needs a new bottom bracket. This one's a bit different to the normal ones, so we'll go through that right now. So starting at the front of this bike, we have the Lux Aero, well, the 3T handlebars, Ergo Nova, an Aero stem. You can adjust the height on this, adjust the inclination, I think it's that type. Headset with oversized bearings. And this is not the fully integrated model, so the front brake is a single caliper through into the carbon foot, which is a HSE7. This is probably one of the best forks you can get for carbon. The frame is, as I said earlier, the 695 Lite, and I'll come to that. The seat post is one of the ones where you have to cut. You do have a bit of adjustment, and there's this elastomeric sort of shock absorber thing there, and you can add some spacers onto it. The rear brake, because this is not the SR model, is up here on the, I think it's the SR or the Aero Lite. The brake is underneath, like a V brake. Front mech is a SRAM red, rear mech is a SRAM red. He's got DT hubs with fast forward rims. I mean, you can see the chain cassette is absolutely immaculate, so it's a chap who really looks after his bike. And then the frame itself is 695, so this is probably one of the best ones that you could get, the 695, and it uses, and it's probably its Achilles heel, a BB65 bottom bracket, and Lux is the only manufacturer that uses that bottom bracket standard. I will show you a picture of that later on, but for now I'll explain what the problem with this is and how we're going to fix it. So this is a Lux BB65 bottom bracket. Now the reason why this has come in here is primarily because the owner of the bike, he was riding along and then he felt his bearings stick. When that happened, the bearing is really hard. This isn't, and it's worn all the way around there. It's not an uncommon fault. It does happen quite frequently, and therefore he wants to move at the same time to a Shimano crankset. So he needs a bottom bracket to do that. To give you an idea of how, over-engineered, if that's the right word, the BB65 is. This is the bearing that normally goes in there, so it's a 6810 bearing. This is a 6806, which is a popular 30mm bearing standard. In fact, it's the de facto standard. I mean, you can see the difference in there, but also there's a cost differential. A genuine one of these, which this one's an NTN one, is around $100, whereas this is considerably cheaper and a lot easier to get. This one is like getting hold of unicorn poo. So the damage on here is probably quite difficult to see on video, but I'll take some pictures so you can see it. It always wears eccentrically because of the pedal motion, because you're only putting load through maybe half the pedal stroke. The other half of the pedal stroke is just a return, effectively. The other thing to note are these two screws up here. I've never seen them before, and I was kind of questioning whether they were Lux originals or not. The chap assures me he got it from a Lux dealer, which is fine, but I've not seen that before. Here we go! Right, remember to check out Hambini.com and Patreon and Hambini Eng on Instagram. I couldn't think of a clean enough PowerPoint title, considering this video is sponsored, so I've just left it at that. But remember to check out my sponsor towards the end of the show. Right, pointer options. Let's check. The pen is working. Yes, the pen is working. Right, moving on. Right, let's rattle through this. The Lux 695. It is
probably one of the best made bikes that you can get, and it came in a few different variations. There was a 695, 695 Lite and the 695 SR. I have worked on all of these bikes, and they're consistently one of the best. It was probably when Lux were at their peak. Now, it originally had a Z2 crank, which is the gold standard of cranks. Technically brilliant. You would be looking at carbon manufacturing pretty much of the highest order. One piece, I've got a next slide to show you about that, but it was commercially flawed, and that's largely due to the lack of adoption of it. It had a quirky bearing standard, you know, this 6-8-10 bearing, and it never really took off because Lux weren't a group set manufacturer, still aren't a group set manufacturer. All they do is make the frames and various aero components, and they're probably most widely known for their pedals. Now, 695 it was a popular bike, but a lot of people are retrofitting Dub 30mm cranks and Shimano cranks, and a lot of the people who buy my bottom brackets are actually Lux dealers. The OE Lux adapter is quite flimsy. Now, just to give you a little shot of the internals of this, this is it. This is the internals of the bike frame. I forget which tube that is, but it is, I think that's actually the seat tube. But anyway, I digress. It's immaculate inside. There's nothing wrong with it. I mean, the bike is obviously not brand new, so you've got bits of dust and dirt in there, but there's nothing on the sidewalls. There's absolutely no tenting, nothing. Inside, now, people have commented before that that they basically, some people in the comments can't seem to tell the difference between wax epoxy overrun and genuine tenting. That is either, well, it's out of focus, but I think it's either wax or epoxy overrun, but the carbon layer beneath hasn't moved, so that is okay. Because of the age of the bike, you can see there's quite a lot of corrosion. Corrosion, that's a rivet by the looks of it. There's corrosion there. Now, I think, oh crap. Now, you rejoin me after I corrected my slide. So, in true PowerPoint fashion, I screwed up. I put one on top of the other. This is quite a good example here of galvanic corrosion. So this, well, it's a set screw or cap edge screw, whatever it is, looks to be steel. This riv nut, looking at it, looks like it's aluminium. You can see the aluminium's been attacked. The steel's got away with it, and there's nothing really on the carbon. The carbon's effectively inert, but the aluminium's taken a hit there, and that's internal. Now, what this means for newer bikes is, you see, newer bikes, they are carbon fibre body with an aluminium insert to take BSA bottom brackets. You're going to get that happening on the inside. You just won't be able to see it. Those kind of bikes aren't really old enough for you to spot it, but I think that is gonna happen. Right, this is the Lux Z2 Crankset. It's one piece, so the whole thing from there all the way around to here is one piece of carbon. It's got some aluminium inserts in here to take those bearings, but it is, really, really good. It's got these things here, which are, I think they call them trilobes, but basically they go into the arms here and here, and they give you, from memory, 170, 172.5 and 175mm options. You've also got this, which is a multi, I don't know why they call it BCD, bolt circle diameter. Normally in engineering you say PCD, which is pitch circle diameter, but anyway. So you can run different chain rings. So most of them came with Praxis. Let me show you a video of that Lux Z crankset.
So this is the Lux Z crankset. There are some interesting features about this. The most obvious one in terms of the ergonomics is this lobe that's in the end there. By rotating that into 3 positions, you've got 170mm, 172 and 175 on the same crank. The other thing that is quite striking about this is one piece made out of carbon. That is technically extremely difficult to do. And in the midst of the one piece carbon, we've also got some interesting things happening in terms of fit. So the bearing on that side is a 6810. The bearing on this side is also 6810, but the bearing on that side is an interference on the inner race. The bearing on this side is an interference on the frame. So if I undo this little lock nut, this bearing pulls off. So that seat there is aluminium. I'm guessing it's aluminium. Feels like aluminium. And the same one on the other side. And they've had to machine some incredibly fine pitch thread into there to give you the preload adjuster. This is the bearing that came out from it, and it is a 6810. This one just says Lux Cycle on it. It might be difficult to read, but it just says Lux Cycle on it. I would say that was an SNR bearing that's just been rebranded to Lux Cycle. It doesn't have any other name on it. What's that say? No, there's no other names on it and there's no other markings, but I think that's an SNR bearing. If you're not familiar with who SNR are, SNR is, or was, the bearing division of the Renault car company. It was spun off and it became an independent company, and then NTN bought them, so now they're called NTN SNR. So if you buy a SNR bearing, you're basically getting an NTN bearing. So that is the crankset. This one is obviously used, well used. There's a couple of things that I noticed on this one. So the bolt here has been changed, and that one has seen better days because the head off that one snapped off. But overall, it's in pretty good nick. I'm Praxis chainring. So this comes with Praxis chainrings. I'm not a fan of Praxis chainrings, to be honest. I don't think they shift all that well. But I guess everyone's different. But yeah, that's just my thought. Now this is a proprietary crankset, so it's called BB65, and that's because the outside diameter of the bearing is 65mm. If I compare that to an NTN bearing, so if I get one out of my pocket, fresh, box fresh. So there's the 6810. And there's a 6806, so that's a BB30 bearing. So the BB65 bearing's massive. So the outside's 65, the inside is 50, versus this one, which is 30 on the inside and 42 on the outside. So this is a huge difference. In terms of width, there's not actually that much different. I think they're the same. I think it's a 7mm bearing. But this one is totally different.
Right, this is a few of the advantages and disadvantages of the BB65. So first of all, it's unlikely to creak by design, basically because it's so big. The bearings are big. It's very stiff. That one-piece carbon crankset that's probably the stiffest you're ever going to get. Not even Tyrone could beat that. I've just explained about the crank length you can change easily. And it's got very high load rating because those bearings are massive. As an implementation, so manufacturing and implementation, it is grade A. Very, very well engineered. Disadvantages: it is a pain in the backside to service because it's got a load of proprietary parts. So you're screwed if you get a problem with it. Not everyone has access to a lathe, and most bike shops aren't going to be familiar with that. I mean, they're going to change Campag and Shimano all the time, but BB65, no chance. And the spares are very, very expensive. So those bearings are a bucket load. They're very, very expensive, and getting hold of them is difficult. This is the bike. You can see the spun bearing pattern. So if you look here, see that, and there, it's off at a slight angle. Normally the wear will be fairly even all the way around, but it's spun. Now if you go from there and actually plot it, this is the typical profile, polar profile that you would get. So if you look, I'm making this up, but no, I'm not making it up, but I'm using this as an example. If you look at that gap there versus that gap there, on the circumference of the circle, it's slightly wider, and that's where it's gone in. I mean, the bearing's hardened steel, the shell isn't. I just mentioned about the deviation. Now, the older bikes came with SNR bearings. Now, SNR was originally, it was a French manufacturer, was originally, if you go back far enough, the bearing division of Renault cars. It was spun off, and then it's, I think the last bit's Roulement, but I can't remember what SN means. Anyway, it's now part of NTN. At some point, and I'm not sure when, they went from SNR to another no-name brand. At that point, things, I think, took a step for the worse. Because those bikes with those bearings, every one I've seen has been rubbish. And that's when the problem started. So if you can get hold of an NTN or an NSK in that size, they're the two that you can really get hold of. That's about it. Now, in terms of cleaning this up, it's actually straightforward because it's so big. 65 millimeters, when you put it into the boring machine, you can clock that quite easily. And the other thing is, there's an internal shoulder inside a Lux bottom bracket, which most of the other ones don't have. In fact, loads of them don't have. So whoever has designed it really has thought about it. So you can do that. Right, so what are the issues? So the issues are, or what we're going for, the customer wanted a removable bottom bracket that you could use hand tools to remove. We have to avoid that centre obstruction, keep alignment and stiffness, that's just a given, and some additional wiggle room to sort out worn shells, because that's becoming a thing now. So tooling, this is possibly one of the reasons that people have commercial success or failure. If I was to explain about tooling, a lot of people have my bottom brackets that watch this video. One of the things that is quite key is to make your tooling and your standards just ones that exist that people have. So all of my bottom brackets use standard size bearings that you can just go and get from anywhere. They may not all be the same quality, and you may get fakes, but they are a standard size. And the parts that are used to install it, M12 or half-inch stud bar, is readily available pretty much all over the world. Half-inch is basically the States, and Canada. M12 is pretty much the rest of the world. It's the same thing that happens in the bike industry, but although I've brought the aero industry into here, I've gone, when I've designed this bottom bracket, and this is it, you're going to see it in the next slide, for non-proprietary tools. So normally most bottom brackets use this type of tool, so this, or a variation of it, for threading anyway. So the load is applied tangentially to tighten. This type of bottom bracket is actually the crank arm of a FSA Gossamer crank. That's a pin spanner that goes in there. So that is one of these. Okay, so what I've done is I've designed my bottom bracket to work with this. This is an industrial one, okay, so it's a bit more heavy duty than the Park Tool one in the slide. This is a Facom. And what this does is this will slot, again you'll see it in a minute, into this collar like this. I've been fiddling around with this. So then you've got the drive to turn it round, and I'll show you that coming up. Right, so that's it. Non-proprietary tooling. Make it standard, make it easy for everyone to handle. Right, let me show you the 3D. So this is the bottom bracket. The bearings I've removed just for show, but you can see how this goes together. So I've kind of color-coded it. Normally, I don't actually use SolidWorks. I use something else. And don't take this as gospel, because I have fiddled with some of the dimensions because people like to copy my stuff. Right, this is a cutaway through the bottom bracket. So this is now in two pieces. So the original one I had was an interference. This one is a transition fit with a locking collar on the end of it. The advantage there is you obviously remove it with hand tools, and because it locks, if there's a bit of deviation on the shell, you don't need such a perfect hole. So you can have, instead of it being like a H or an IT7, you could go to like an IT9 or IT11. So that's like the variation. So IT7 on 65 mils, maybe, you know, 0.05 of a millimeter for it to work properly. With a locking collar, you can have probably a tenth and a half. So it gives you a much wider range to work with. This purple thing or pink thing is the locking collar, and what I've done is it's threaded. Now the threads only stick out by one thread, two threads. The main reason for that is you don't want loads of threads sticking out, because you get full of crap and then it becomes difficult to install and remove it. So that's it on screen, and this is it in real life. So this is the one piece and this is the other piece. You put it in and then screw it together like that. You're about to see that shortly. So this fit and this fit are transition fits. That's the main difference between this one and the fully press fit one I had before. Well, I still have. Fully pressed fit is, you know, fully pressed fitted. So this part is bigger than the frame, whereas on this it's almost size for size. This is actually ever so slightly bigger than the one on the frame, but it's not such a huge grab. Right, without further ado, let's go back and fit this. If you are one of the regular viewers of the channel, you will know about the extensive use of numerical modelling that I do on here. Now that would not be possible without Skillshare, who are kindly sponsoring today's video. Now Skillshare is just a bit more than a learning platform. It allows you to interact, grow and succeed in tasks that you may have otherwise found somewhat challenging. In my case, I joined Skillshare for two primary reasons. The first was to improve my German, and the second, which is a lot more relevant and you've just seen, was to improve my Excel visualization skills. So it appeals to a wider range of people, such as those viewing the channel. Now, the course that I would recommend is this one, which is called Microsoft Excel Essentials Level 3 VBA Programming by Alan Jarvis. Now I found this course to be quite engaging and pitched at just the right level. He covers everything like visualization strategies for wider audiences, some of the key coding, and also fine levels of customization that give you the tools to adapt what you've learned to your particular situation. If you are interested in becoming a member of Skillshare, the first 1,000 people to use the link or my code Hambini will get a month free trial of Skillshare.
So this is the bottom bracket. It is a one piece with a locking collar. So the bearings are still perfectly aligned. The difficult bit is not really in there, it was in the tooling. So the tooling is this. So this is one I've made earlier. So the key point here is this is driven at 90 degrees to normal. So a lot of them, like BSA bottom brackets, the drive is around the outside. On this one, the drive is perpendicular. So it's like that. Yeah. Those are hardened pins, and these little rubber O-rings are there to stop you damaging the surface, because the tool is much harder than the bottom bracket, and there's a hole through there just in case we need to put a stud through just to hold it all in. And this is one that hasn't been built yet, but the pins go in here, so it's an interference fit which I'll need to put in, and then we need to push that through, and then away we go. So I've pushed 3 of the pins through on my vise, just got that one left to do. Here we go, just pushing that in. So that's done. Back it off a bit. And there we are. So we've cleaned this up, gave it a little bit of a tickle just to get rid of some of the, I guess, the low spots and get the sizing correct. I'm going to just clean it again because the pedantic amongst people will otherwise crucify me in the comments because I'm so dirty. Well, that's what the hairdresser says anyway. This is probably overkill, but that doesn't matter. So we're going to spray it with activator. Wipe off the excess, let it evaporate, and then we're going to install the bottom bracket with some retaining compound as well, just for a belt and braces. So the way this is going to go is that is the drive side and that is the non-drive side. That goes in there and this will screw in and tighten up while giving a transition fit on here. This is my grease gun and it's got Mobil in it, so we're going to pump a little bit out and then put some of the Mobil SHC onto the threads. So if you are going to use grease, this is probably the best one that you can get. Let's get some more. And now we're just about ready to install it. Just stress, normally I put my bearings in the bottom bracket before I put it in. This is mainly just for photographic purposes in this video. Now I'm going to apply some medium strength retaining compound onto the seats. A liberal amount today. Okay. So that will take 3 days to achieve fullish strength, I would say. So I wouldn't recommend you use it for 3 days. So I've just got this started. So this one's just in and I've got the 2 tools. Now that one will locate at the back. And for now, because the fits are pretty much as good as I can make them, you could just turn this by hand. But if you've got something that's a bit stiffer, then it may be a bit more difficult. So that is quite stiff to turn, but it is turning. Might have to get the spanner on it in a minute. But before that, I'm going to put a stud through here because that is going to fall off. So all I've done here is I've put a stud through. All my gear is M12, or I standardise on metric, A standard, it's nothing obscure. At the back you can see my usual press handle. I've just put that over there because it's just easier. On this side I've just put a nut so that you can see. And then this is a 24mm wrench or spanner, and we're just going to tighten this up. Right, so now the other side's turning, so we're going to have to get a spanner onto that side as well. So all that is now tightened, so we can remove the stud and remove the tooling. So now the other side's seated, and because of the way this is designed, it's not going to move. Got the tool and torque wrench, so we're going to put 40 Newton meters into there. So that's a pass. Now we can put the bearings in and then get this bad boy boxed up. So this is the non-drive side of the bike. You can see this side, which was designed to be like this, is slightly proud by about 1 or 2 millimeters. It's because it's the collar size, so you need to have as much material as possible, and the threads are there, and I'm engineered it so you'd only ever get one thread showing. The reason for that is because you don't want crap and muck building up in there, and then it becomes a pain to get it off. Hence, there's only one thread showing, which is the minimum amount that you can get away with. So the bottom bracket's seated. We'll just put some grease in there because I know some of you prefer it when I grease tight holes up rather than use reaming methods. I'll save those reaming methods for the bedroom or the couch or the washing machine. Anyway, we're going to put the bearings in, which are these, and then put the crank through. So the bearings are in, I put the caps in, and now we're just going to put the crank through. It is a 105 crank, the chap supplied this. Put the arm and the preload collar on the other side. So we're just going to do this up now and then hopefully give it a turn and see what it's like. I'm quite optimistic. So I've done it, I've put it on and I put just a tinkle of preload on, and we have a fairly good result. If I give it a little bit more, it goes a bit faster. And that brings us to the end of this video. I really hope you enjoyed that masterclass in, well, I'm not sure how you could best describe it, but if you've got any questions, comments or anything like that, please do comment below. Remember to smash that like button and hit subscribe if you want more idiotic content. And as always, keep banging your hairdresser.